This is the example video for key components of linear equations in standard form. So my goal for these problems, I want to find the x-intercept and I want to find the y-intercept. So down here, I'll put x-intercept and I'll put y-intercept. Okay, and I can already make my ordered pairs. And I know for my x-intercept, I'm plugging in a 0 for y. And for my y-intercept, I'm plugging in a 0 for x. Okay, so look at that. I already have my answer done. So I'll go up here. I'll do my x-intercept first. Doesn't matter which one you choose. So for my x-intercept, I'm plugging in 0 for y. And for my y-intercept, I will plug in 0 for x. Okay, just like I did down here in my solution. So doing the x-intercept first, I'll have 5x minus 7 times 0 equals 35. So negative 7 times 0, that cancels out, so I'm left with 5x equals 35. To get the x by itself, I'll divide both sides by 5. These 5's cancel. So I end up getting x equals 35 divided by 5, which of course is 7. Okay, so this 7 is what we will plug in for x for our x-intercept. So we know this line crosses the x-axis at the point 7, 0. So now I'll do the y-intercept, and I'll go right up here. So I have 5, instead of x I'm plugging in 0, and it's 5 times 0, it's not 50, minus 7y equals 35. So when I do the math, 5 times 0 is 0, so I'm left with negative 7y equals 35. I'll divide both sides by negative 7. These negative 7's cancel. So I get y equals 35 divided by negative 7, which I know is negative 5. So this negative 5 is what I will plug in for my y down here. So this line crosses the y-axis at the point 0, negative 5. So this is what I would be looking for down here. Okay? So let me erase here. And I'll move on to the next problem. Again, you can always pause the video if you need more time. Okay, so I'll do my x-intercept again over here. So I've got 9x minus 7 times 0 equals 28. So I get 9x equals 28 because negative 7 times 0 is 0. So now I'll divide both sides by 9. So these 9's cancel. So I get x equals 28 over 9. And if you can simplify this fraction, please do. But there's no number that goes into 28 that also goes into 9 evenly. So our x-intercept get rid of these. As I was saying, our x-intercept will be 28 over 9, comma 0. Okay? So now we'll do the y-intercept. So we have 9 times 0 minus 7y equals 28. So 9 times 0, that cancels. So we're left with negative 7y equals 28. I'll divide both sides by negative 7. Those negative 7's cancel. So we get y equals 28 divided by negative 7. And 28 divided by negative 7 is negative 4. So we can take that negative 4 and plug it into our ordered pair down here. Okay? And if we actually did want to see what this x-intercept was, I'm not exactly sure what 28 divided by 9 is off the top of my head, but if we were to plug that into a calculator, we would get some sort of decimal. Okay, so this line does not cross the x-axis at a lattice point, meaning at two whole numbers. Okay, crosses at a decimal, comma 0, and crosses the y-axis at 0, negative 4. Okay, so I will erase. If I'm going too fast, as always, please pause the video. And let's move on to the next one. So let's do the y-intercept first this time. So we will have 0 plugged in for x minus 7y equals negative 35. So we've got a 0 there. So we're left with negative 7y equals negative 35. Divide both sides by negative 7. These negative 7's cancel. So y equals negative 35 divided by negative 7, which is a positive 5. Therefore, we can plug in 5 for our y-intercept down there. So we know this line crosses the y-axis at the point 0, 5. Now if we're going to do the x-intercept, this one's an easier one. We're left with x minus 7 times 0 equals negative 35. So negative 7 times 0, that cancels. So we're left with x equals negative 35. And because the x is already alone, it has a coefficient of 1, we can take that negative 35 and plug it in over here. So this line crosses the x-axis at the point negative 35, 0. As I mentioned earlier, don't be afraid if you are left with a fraction. Don't assume you did anything wrong. That 100% can happen. And actually, a lot of the time, if you think about it, it makes sense that it does happen. Okay, so let's move on to our next problem. Okay, this one right here. This one's a little bit different. So if I were to graph this one, you don't have to make a sketch of this graph, but I will. Remember, this is my y-axis, this is my x-axis. So this is saying x equals negative 29. X equals negative 29 all the time. Okay, so no matter what our y-coordinate is, our x will always be negative 29. So let's say we had negative 29. Of course, this is not to scale, and it's right there. Okay? So I've got this line that goes through negative 29, and it keeps going on forever in both directions. It is a straight vertical line. So it's pretty easy to see that this vertical line crosses the x-axis at negative 29. But because it is a vertical line and our y-axis is also vertical, these two lines are going to be parallel. So when they're parallel, that means that this line, x equals negative 29, will never actually cross the y-axis. So because of that, we can erase our y-intercept right here and put none. You could also put no y-intercept, okay? Because at no point will this line ever cross our y-axis. Okay? Pause video if you need more time. Okay, and I'll get set up again. Okay, now let's move on to number 5. For number 5, let's do the x-intercept first. So we have 2x plus 0 equals negative 6. Okay, I don't need to rewrite that 0, so we're left with 2x equals negative 6. I can divide both sides by 2. These 2's cancel. So we're left with x equals negative 6 divided by 2. And negative 6 divided by 2 is negative 3. So I'll take that negative 3 and I'll plug it in for my x-coordinate over here. So this line crosses the x-axis at the point negative 3, 0. Now we can do the y-intercept. So we'll do that by plugging in 0 for x, and it's 2 times 0, it's not 20, plus y equals negative 6. So 2 times 0, gone, cancels, so we're left with y equals negative 6. And because we have no coefficient or number in front of our y, we know that our y-coordinate down here will be negative 6. So this line crosses the y-axis at the point 0, negative 6. I'll erase, and we're moving on. Okay, number 6, last problem. So for number 6, let's do the y-intercept first this time. So we have 2 times 0 plus y equals 4. So 2 times 0, that cancels out, much like the last problem, and we have y equals 4. So since the y is by itself, I can plug in 4 down here. And now let's find the x-intercept. So we have 2x plus 0 equals 4. So no need to write 0. We have 2x equals 4. I'll divide by 2 on both sides. These 2's cancel on the left side to get the x by itself, and x equals 4 divided by 2, which of course we know is 2. So this line crosses the x-axis at the point 2, 0, and crosses the y-axis at the point 0, 4. At this time, to sharpen your skills a little bit, I recommend moving on to key components of linear equations in standard form practice.